Imagine a world where materials could change shape on demand, transforming their structure and functionality as needed. Picture objects morphing, adapting, and even repairing themselves, seamlessly integrating into their environment. This is the promise of programmable matter and 4D printing, a groundbreaking leap in material science and engineering. These technologies, though still in their early stages, hold the potential to revolutionize fields from manufacturing and medicine to construction and beyond. Imagine buildings that can repair themselves after an earthquake or medical implants that adapt to the body's needs. Programmable matter refers to tiny self-assembling robots or particles that can rearrange themselves to form different shapes, offering unprecedented flexibility and adaptability. 4D printing takes this concept a step further, adding the dimension of time to the equation. It involves creating three-dimensional objects that can change their form or function over time in response to external stimuli, such as heat, light, or moisture. These technologies sound like science fiction, but they are rapidly becoming our reality, pushing the boundaries of what we thought possible. Join us on a journey to explore the fascinating world of programmable matter and 4D printing, where the line between imagination and reality blurs. We'll delve into how they work, their current applications, and their potential to reshape our future, transforming industries and everyday life in ways we are only beginning to understand. At the heart of programmable matter lies the concept of modularity. Imagine tiny, self-contained robots called catoms, short for Claytronics atoms. These catoms are the building blocks of programmable matter. Each catom can connect, communicate, and move relative to its neighbors. These microscopic robots can be programmed to assemble into a vast array of structures. Think of them like digital clay, capable of morphing from a phone to a spoon to a wrench in the blink of an eye. The possibilities are limited only by our imagination. One of the most fascinating aspects of programmable matter is its ability to self-assemble. By programming simple rules into each catom, scientists can create complex structures without the need for human intervention. These rules might dictate how catoms attract or repel each other, how they move, and how they respond to external stimuli. From these simple instructions, intricate patterns and structures can emerge, much like the way cells organize themselves into tissues and organs. While programmable matter focuses on creating reconfigurable materials, 4D printing takes a slightly different approach. It centers around building objects that can change their shape, properties, or functionality over time. Imagine printing a flat sheet of material that, when exposed to heat or water, folds itself into a complex three-dimensional structure. This is the essence of 4D printing. It's about embedding transformation into the very fabric of an object. Section 5. Printing the future. How 4D printing works. 4D printing relies on smart materials that can respond to external stimuli. These materials are often polymers with unique properties, allowing them to change shape, size, or even color in response to factors like temperature, light, or pressure. The printing process itself is similar to traditional 3D printing. However, instead of using a single material, 4D printing incorporates multiple materials with different properties. This allows for the creation of objects with embedded instructions that dictate how they will transform over time. Section 6. Real-world wonders, current applications of programmable matter and 4D printing. Though still in their early stages, programmable matter and 4D printing are already making their mark in various fields. Self-healing materials. Imagine a world where cracks in your phone screen could repair themselves. Scientists are developing self-healing materials using programmable matter that can detect and repair damage, increasing product lifespan and reducing waste. Adaptive clothing. 4D printing enables the creation of clothing that can adapt to changing weather conditions. Imagine a jacket that automatically adjusts its insulation based on the temperature, keeping you comfortable in any environment. Targeted drug delivery. In medicine, 4D printing offers the potential for targeted drug delivery. Imagine ingesting a tiny robot that travels to a specific location in your body and releases medication precisely where it's needed. Section 7. A world transformed potential future impacts. The potential applications of programmable matter and 4D printing are vast and varied, offering a glimpse into a future where the boundaries of innovation are constantly pushed. Let's explore how these groundbreaking technologies could transform our world in ways we can only begin to imagine. revolutionizing manufacturing. Imagine factories without traditional assembly lines, where products are not just assembled, but grown from programmable matter, allowing for unprecedented flexibility and creativity in design. This could lead to more efficient production processes, reducing waste and increasing sustainability. Additionally, it would enable the creation of customized goods tailored to individual needs, making mass personalization a reality, transforming construction. Imagine buildings that could adapt to changing environmental conditions, shifting and evolving as needed, or even repair themselves when damaged. 4D printing could revolutionize construction, allowing for the creation of dynamic structures that respond to their environment. This technology could lead to the development of buildings that are more sustainable, using green materials and methods that reduce the carbon footprint. These structures would be resilient, capable of withstanding natural disasters, and responsive to their surroundings, enhancing both safety and comfort. Reshaping space exploration. Imagine sending a compact payload into space that could then unfold and assemble into a complex structure, such as a space station or a lunar habitat, providing new opportunities for long-term space missions. This innovation could drastically reduce the cost and complexity of space missions, making space exploration more accessible and feasible. With these advancements, the dream of living and working in space could become a reality, opening up new frontiers for humanity. Healthcare revolutionized personalized medicine and beyond. The healthcare industry stands to benefit immensely from programmable matter and 4D printing. Imagine a future where personalized medicine allows doctors to use 4D printing to create custom implants and prosthetics tailored to a patient's anatomy and needs. This would lead to better outcomes, faster recovery times, and improved quality of life. Programmable matter could revolutionize regenerative medicine as well. Scientists envision using it to grow new tissues and organs, potentially eliminating the need for organ donation. Minimally invasive surgeries could also see a transformation, with tiny robots made from programmable matter performing complex surgeries with minimal incisions, reducing pain, recovery time, and the risk of complications. Building smarter infrastructure transformed. Programmable matter and 4D printing could revolutionize our infrastructure, creating cities that are smarter, more efficient, and more resilient. Imagine self-healing roads and bridges that could repair potholes automatically, or adapt to changing traffic loads. 4D printing could create infrastructure that is more durable, safer, and requires less maintenance. Dynamic urban environments could become a reality, with buildings adjusting their shape and functionality throughout the day, transforming from offices to apartments to entertainment venues as needed. This could lead to more efficient use of space and resources in densely populated areas. Sustainable living could be achieved with cities adapting to changing environmental conditions, reducing their ecological footprint. 4D printing could be used to create buildings that generate their energy, collect and purify water, and even clean the air around them. The ethical frontier, addressing the challenges of emerging technologies. As we stand on the brink of a new technological era, it is crucial to navigate these uncharted waters with caution and foresight. As with any powerful technology, programmable matter and 4D printing raise ethical considerations that we must address. These innovations hold immense potential, but they also come with responsibilities that we cannot ignore. Job displacement is a significant concern, as the automation potential of these technologies could lead to job losses in manufacturing, construction, and other sectors. The ripple effects could be felt across various industries, affecting millions of workers worldwide. We need to prepare for these changes and ensure that workers have the skills and support they need to thrive in a changing job market. This means investing in education and vocational training programs that can help workers transition to new roles. The environmental impact is another important issue, as the production and disposal of programmable matter and 4D printed objects could have environmental consequences. We must be vigilant about the potential for increased pollution and waste. We need to develop sustainable manufacturing processes and materials to minimize our ecological footprint. This involves researching and implementing eco-friendly alternatives that can reduce the negative impact on our planet. Access and equity must also be considered, ensuring that the benefits of these technologies are accessible to all, regardless of income or geographical location. Bridging the digital divide is essential for fostering inclusive growth and development. This will require careful planning and investment to prevent a widening of the gap between the haves and the have-nots. Policymakers, industry leaders, and communities must work together to create a balanced and equitable technological future for everyone. A future shaped by innovation, the promise and responsibility of programmable matter. Programmable matter and 4D printing hold immense promise for a future where materials are no longer static but dynamic and responsive. These technologies have the potential to revolutionize industries, improve our lives, and address some of the world's most pressing challenges. However, it is our responsibility to guide the development and application of these technologies responsibly and ethically. By carefully considering the potential benefits and challenges, we can harness the power of programmable matter and 4D printing to create a brighter future for all.